Hello, Chem students. This is yours truly, Professor Ship, and I want to go ahead and share with you guys one of these requested videos. A student emailed me and said, hey, can you do a video where you're showing us how to draw out the molecular structures that have brackets? I said, you know what? That's a good idea. I never thought about doing that one. So I'm going to go ahead and share with you guys how to draw molecular structures when you have brackets, such as, let's say, phosphate ions. And what we mean by brackets is when you normally draw a structure, you normally have the structure like water, H2O. You draw your hydrogens on both sides of the oxygen atom, oxygen's right there in the middle, and you don't have brackets around it because it doesn't have an extra ionic charge. The way you know that you're going to need brackets is if you were given a molecule and it had a charge attached to it. It's typically your polyatomic ions. So let's get into it, okay? Let's go ahead. All right, chemistry students. So let's look at cyanide. Cyanide. So we've got carbon and we have nitrogen. We've got one carbon, one nitrogen. Based on the subscripts that you do not see, that tells you one. You have one of each. So carbon is in group 14, so it's going to contribute 4 valence electrons. We've got nitrogen that's in group 15, so it's going to contribute 5 valence electrons. Now remember, when you add them up, you got that odd number. What do we say about odd numbers? You don't want them. They always got to be even. So therefore, guess where we're going to get that extra number from? You got it from that negative charge up here that's attached to that cyanide structure. And by the way, this all these numbers that you see that are subscript written, those are considered polyatomic ions. Cyanide is one of them. Okay, so what I'm going to do, because it's a negative charge, you're going to do what? Add that number to it. Okay, plus 1. So you end up with 10 valence electrons. Now we're going to go ahead and do our bookkeeping again and draw 1, 2, 3, and 4. And then nitrogen over here has 5. 1, 2, 3, 4, and 5. Now, again, you can just use this pre-drawing to just check off as you complete the problem. Okay, it don't matter, all right? Here's carbon. Now, check this out. Because you only have 2 elements, carbon and nitrogen, you can go ahead and pair them together. Your 2 here and your 2 there. Okay, because you're not going to have another element at the very top of carbon, and you're not going to have another element at the bottom of carbon. So you might as well pair them together, okay? Now, and what do I mean by that? Anytime there's a valence electron, that means that is a space where another element can be attached. It's kind of like saying, hey, I'm open. I need you to attach to me, okay? That's what that means. But because you only have 2 elements, carbon and nitrogen are going to be side by side. So therefore, you're just going to go ahead and draw or pair your 2 carbon valence electrons together. Now, something else I need to show you, since I'm talking about this, I'm going to show you a molecular structure of what they actually look like. I have some chemistry toys I want to show you, so that way you'll get the idea of what we're referencing here, okay? But let me go ahead and finish this problem so you all can see it to completion. We're going to go ahead and bring in our nitrogen with how many? 5. So that's 1, 2, 3, 4, and 5. And then we can't forget about that extra one here from that charge right there. So we're going to add it here, okay? Now, if we go ahead and count out the number of valence electrons that we have surrounding nitrogen, we have 8. Okay, you got 6 of those orange ones plus that green one gives you 8. But then if you look at carbon, carbon only has 4. Remember, carbon and nitrogen both need 8 because they're part of those elements that must have 8 around it. And that's where those double and triple bonds come into play. So guess what I'm going to do? Since nitrogen is full, we're going to share those. We're going to take the 2 at the very top and move them right here in the middle. Okay? So we still have 2, 4, 6, 8 around nitrogen, but guess what? We only have 6 around carbon. So what we're going to have to do is take those extra 2 on the very bottom and move them right here. Okay? So here we go. We got those 2 right there. And guess what? You're going to replace those dashes here, or those little dots in the middle, with dashes. Bonds, that is. Okay? And here's your picture, your final image. And put that in brackets with that -1 on the outside, or you can just put negative, okay? Negative or -1, tomato, tomato, they mean the same thing. And you are done, okay? All right. Cyanide, okay? You've got carbon, which is the black element, okay? And then you have your nitrogen, which is blue. But remember, carbon formed that triple bond with nitrogen. So therefore, I'm going to have to use my little flexies here to show that they're going to connect to nitrogen. And here's nitrogen right here. And now we're going to form those triple bonds right there, okay? And as a result, this is carbon here in the middle, okay? Not in the middle. This is carbon right here, and it's forming that triple bond with those nitrogen, with that nitrogen atom. And that's what cyanide looks like from a chemist standpoint, okay? Not that y'all care about that, but this is just to give you a visual so you can see it. And you can do this with gumdrops or leftover Halloween candy or leftover Easter candy, whatever, okay? You can do this, okay?